Hey everyone, my name is Raj Abdul Rahman, student ID 4331626, and this is the video presentation for Data Management Coursework 1. So before anything, here's my student ID. Alright, so let's begin. So I'll start off by giving a brief introduction about the coursework. So basically, the goal of this coursework was to write a IEEE compliant academic paper based on structured literature review. So my topic was AI observability in master data management. And honestly, at the start, I didn't even realize how deep this area actually goes. So the whole point of the report was to look at four observability dimensions. So there are actually four major observability dimensions inside the MDM systems. So data quality and drift detection, explainability and interpretability, and RCA, root cause analysis, and security and compliance monitoring. So, and then further on, the goal was to evaluate what the current research is saying, what the gaps are, and what still needs to be worked upon. So coming towards how I actually conduct my research and the sources used. So the first thing I did was go to Google Scholar and search using combinations like AI observability, concept drift monitoring, survey of AI observability tools in master data management, XAI in MDM or explainable artificial intelligence, model monitoring, even terms like ML security and security and compliance to GDPR in AI observability. So in this manner, I ended up selecting 11 peer-reviewed academic papers, plus one well-established technical article from, what was it called again? Evidently AI. So the paper I picked were all recent studies, like we're talking about from 2020 to 2024, because the field moves fast, and older papers didn't match the current industry context, especially when it comes to uh, establishing the current state of the art of the technology. So I focused on service and systematic reviews because I needed broad coverage, not single case studies. And single case studies, for example, it may only apply to medical imaging or financial fields, but for a broader surveys, basically, one of the paper that I selected actually reviewed more than 45 case studies. That's a lot. So I basically selected A grade quality research papers. So talking about the sources I rejected, so I also rejected quite a lot of resources because some were basically too old, like one from 2013, one from 2025. The papers that didn't really reflect the modern AI pipelines and state of the art these days. Some were vendor blogs that sounded nice on paper but had zero academic rigor or any uh, sources to verify their credibility even. So there were many others which talked about generic data governance, but didn't really connect the observability tools with them at all. So basically, if a source didn't clearly contribute to one of the four observability dimensions that I just mentioned, I didn't use them at all. So what the literature says or the state of the art. So from the papers, I found that concept drift and data quality monitoring is the most mature area when it comes to the literature. So there are tons of drift detection methods, statistical tests, reconstruction-based tests, semi-supervised, supervised, and even unsupervised detectors. And but the main problem is hardly any of them integrate cleanly into enterprise MDM systems because most research is based on controlled data sets, synthetic data, not really the real representation of all that messy and random jargon of enterprise data. So for explainability, again, the research is strong. For example, SHAP algorithm, Lime, counterfactual, factuals, attention maps, which are basically heat maps. But none of these methods are designed for a single model. Sorry, most of these methods are designed for a single model in particular, but none of them basically scale effectively to multiple applications. So another thing is MDM uses multiple models, chained together in real life. So explanations don't stay consistent across all the pipelines. That's one of the main gap that I identified here. So talking about the root cause analysis, it was actually one of the weakest of the four dimensions. So for example, the monitoring tool can tell you that drift happened, right? Or performance degraded, but they don't actually tell you why. We actually need a feature level explanation as to why the model deviated from its actual accuracy. So and we also, not only that, we also need context relevant explanation of those degrading uh, features which are leading to downstream model performance degradation. The research suggests that we basically have a link between observability logs and business processes that are leading to such degradations. But there's almost nothing practical out there. And then comes the security and compliance. So this is interesting because the observability layer by itself can leak information. It can be an attack vector all by itself. So most of the studies, they actually effectively evaluated and reviewed the compliance of observability tools uh, with laws and regulations such as GDPR, etc. But none of them actually focused on considering the observability tool layer by itself being the attack surface. So attacks like membership inference or model extraction can literally just be launched by looking at the monitoring dashboards itself. So future systems need privacy preserving observability. Maybe there are two techniques which were touched upon, which actually aim to solve such security concerns, which are differential privacy and encrypted logging, basically cryptographically signed uh, logs. So how I identified open research issues. So basically, once I understood the state of the art, I compared the four areas or dimensions and looked at where the gaps were. So the biggest issue is fragmentation. So basically, all four observability tool dimensions are treated separately in research. Drift people do their own thing. XAI people, the explainable artificial intelligence people, they do their own thing separately. Security people do their own thing. But in real life, in real enterprise MDM environment, all of this needs to work together collectively and collaboratively. So another gap is lack of automation, like auto remedial actions based on identified causes. If you're talking about root cause analysis, for example, so observability tools detect issues, right? But they don't fix anything by themselves. Don't link them to governance workflows, or don't give process level explanations, as I've just already talked about. And finally, evaluation almost you know, no long-term MDM benchmarks exist. Everything is short-term data sets. There is no shared standard for measuring observability effectiveness. Uh, and Basically, it all sounds really nice on theory, on paper, but in terms of real life application, it's still pretty immature, to say the least. So, talking about the challenges I faced undertaking this coursework. So, for me personally speaking, the hardest part wasn't just reading or understanding the papers. It actually was condensing all of that deep information, all the fruitful research and insights into just 3,000 words only, and without losing important details. So another challenge was understanding how the four dimensions actually interconnected with each other. The studies looked separately at at each of them, but once you go deeper, you realize that observability is actually a whole ecosystem all by itself. So writing in IEEE style, that's also a challenge. And overall, doing this coursework, basically talking about my self-reflection, if I say, it was really insightful. I really did learn quite a lot about AI observability tools and different techniques to identify, concept drifts, let's just say, like Jason Shannon divergence methods, JSD, using JSON star algorithm, for example, and SHAP, Lime, contextual heat maps, all that stuff for explainable artificial intelligence, for example. So all of them were pretty neat and useful things to learn about, and highly relevant to my field and future scope of my degree. So I'm really basically thankful to be able to understand those concepts properly. And another thing is that one of the key takeaways from the study is that you can't just train a model and put it in an actual real life MDM enterprise environment and hope for the best, right? So explanations, the root cause analysis, security controls, the whole system basically goes unreliable real fast if any of the four dimensions are underlooked for just a brief moment. So this assignment essentially taught me how to analyze research properly, how to synthesize the critical overview of the research, state of the art, and basically how to extract meaningful gaps that actually matter. All right, that was everything as far as my presentation is concerned. Thank you so much for watching.